Hello, and welcome back to the Convection Connection. Today, in episode 4, Larry Green and I will explain why balloons, bowling balls, and soda cans sink or float.
So the question today is, why does the helium balloon rise? We know if we take a balloon, we fill it with helium, and then let go of it, it's going to go way up in the sky. But why?
That's right, Larry. Now, the fact that the balloon goes up when we let it go is proof that there's some upward force on the balloon, an upward force greater than the downward pull of gravity, otherwise it wouldn't go up. That upward force is called the buoyant force. There's an upward buoyant force on this balloon because the air pressure on the bottom side of the balloon is a little bit greater than the air pressure on the top side of the balloon. But this doesn't just happen with helium balloons. Notice that the bottom layer of cheerleaders has to exert a great pressure to hold up the layers above. The same thing happens in a fluid. Whether you're at the bottom of an ocean of water or, like us, at the bottom of an ocean of air, there's a tremendous pressure because the bottom layers of fluid have to support the weight of the upper layers. In the case of air, the weight of the upper layers compresses the bottom layers, so the lower air is more dense as well as at higher pressure. Let's look again at the helium balloon. The air near the bottom of the balloon is more dense than the air near the top of the balloon. So there are more molecules pounding on the bottom of the balloon than on the top of the balloon, and there is a net upward buoyant force.
The word buoyancy brings to mind buoys, boats, things that float in water. So I guess the principle applies to water too.
That's exactly right. It's exactly the same principle in water. But it doesn't have to be just buoys or boats that floats in water. For instance, do you think this bowling ball will float in water?
Well, I don't know. There's a good way to check. It does.
Yeah, this is actually a kiddie bowling ball. It weighs 6 pounds. The upward buoyant force from the water is greater than the weight of the bowling ball, so it floats. Another example is, I have here regular Pepsi and Diet Pepsi. What do you think will happen when we put those in water?
Oh, you think there's a difference? Let's try it out. Here's the regular. That one sinks. And now the Diet. That guy floats.
That's right. The regular Pepsi has a lot of sugar dissolved in it, and that makes it more dense than water, so it sinks.
Well, it develops another case for drinking diet soda.
I guess that's why they call it light soda. Next time on the Convection Connection, join Larry and me when it's our turn to float in the air.